What's going on, my friends? Today we will talk about how VOIP systems, and specifically those hosted on the web, can be hacked with just a couple of commands executed on the terminal. We will solve the TryHackMe Billing challenge that exactly allows us to demonstrate hacking VOIP web applications. So let's do
The
this.
first step is doing the Nmap scan. And here I use two commands. The first command, I started it with scanning the IP address or the target to reveal the services and their version and use the base scripting engine or the scripting scan. And we can see here that we have 3 open ports revealed in the scan. However, upon trying to use the -p option, so -p- in Nmap allows you to scan for the full port range. And since the scan takes some time to finish, I use the -t4. Now -t4 is a method to increase the speed of the scan. However, it comes on the expenses of the scan stealthiness. So basically when you increase the speed of the scan becomes less stealthy and more noisy. Basically you have like 4 ranges, starting with 1 and ending with 4. So you have 4 ranges or 4 level of speed you can use in your scan. Now, since we are scanning a machine that we control and we know it is vulnerable, we can easily set the scan to use -t4 to increase the speed of the scan without worrying about firewalls and intrusion detection systems. So when doing that, we discovered an additional open port, 5038, and it is running a service named Asterisk. Asterisk call manager, and the version is also revealed. Now your next step is to decide which port you want to dig deeper. So basically we can start with port 80 and have a look at the web application running on this machine. Now upon opening the web application, we can see that it is running on /mbilling, and it is a login page. Now we're still in the enumeration phase of this penetration testing. That's why we need to gather more information before we decide to engage in any form of exploitation or maybe brute forcing. Now one thing we want to know is the version and the name of the app running. So here we can see that by looking at the tab, we can see the name is MagnusBilling. Okay. Now MagnusBilling is a billing system used to issue bills. So it's actually categorized as a financial application. Now you can view the source code of this application by going to this or by visiting this repository in github.com. You can see that the name is MagnusBilling, and basically we can see the main source code. It's also worth mentioning that the location of this source code is under library, and then you have the ISPay. You have the base files, right? How it handles different sorts of payment methods and the verification of every payment. And here is the main code. It's under ispay.php. It's a PHP code. We will actually go over this in a while. Okay, if we go back to the application here, another thing we want to know is the version of the application. Determining the version or discovering the version allows us to view what are the potential vulnerabilities associated with this version. Now, if you don't see any links, any helpful links at the bottom of the screen or by viewing the page source, you should find related links that allows you to view to find the version. Let's see here. So the source code looks like there is no hints about the version. Maybe we can search if we use the version. Okay, we have a match here, but this is a match for the user agent. It's not related to the application. If we search for ReadMe, maybe ReadMe, also we don't find any matches. So viewing the page source did not help in this case. Now if you go back and we try to access maybe robots, nothing in here. You can do that at the root of the application as well, robots. And we have an issue here. Another thing you can try is assuming that there is a README file. Now basically here, every application has an associated README file. Now if you search for README here, as you can see, there is a README file here. If we try to access this at the running application, it should be actually written in a uppercase form, and there is a match. If we read through this, we can see that the version, yeah, there is a versioning section here, and you see that we are in the Magnus Billing version 7. Now we know the version, it's time now to search for vulnerabilities. So we type the name of the application followed by the version and the keyword CVE. You can see that we have a couple of listings. Now the first one, the first link, it's about command injection. And I already opened this link here. So if you read through the link, you can see a command injection vulnerability exists in Magnus Billing version 6 and 7. The vulnerability allows an unauthenticated user to execute arbitrary OS commands on the host with the privileges of the web server. So this means that if we are successful at executing remote commands on the host or the application, and if we are successful at getting shell, we will get the shell with the privileges of the web server user, www data. Affected products, 6 all versions, and 7 up to and including commit. So probably the version we have here is vulnerable. Steps to reproduce the following proof of concept uses a harmless sleep command as a payload. So see here, we actually first visit this file. So basically, we want to trigger the main code, or the main code that's responsible for the vulnerability. So why here though? Because here's the codes. A piece of demonstration code is present at lib ispay.php with a call to exec function at line 753. Let's see here the main code. If we go to the ispay, the designated path, and we search for exec, you can see here this if statement. So the if statement here checks if the demo variable is provided in the get request. So if it is provided, we can see here another if statement that also checks if the demo C. Now we have two parameters, demo and demo C. So the exec occurs or actually exists in both if statements, here and here. Now the thing is, if you go back to the advisory, a piece of demonstration code is present with a call to exec at line 753. So we are here. So I have to examine this if statement. So the first one, the first line, 751, examines if demo C is provided and if it is more than 5 characters in length. Using str length, we can measure the length of the provided parameters. Now, if it is more than 5 characters in length, if these two conditions are met, this line is executed. So we see here there is a command, it's passed directly, the parameter is passed directly into an exec function to execute the system command. In our case here, it is touch. So the problem here is the parameter, demo C, is passed directly to a system command or a function that executes a system command without any sort of validation or checks. It doesn't check if the demo C parameter contain some malicious characters or system commands. It directly plugs the parameter into a function that executes system commands. That makes it vulnerable to command injection. So that's the cause. Now, in order to do a proof of concept, we're gonna have to try to trigger the vulnerability by visiting or by sending a GET request to this path. Okay, and we provide the demo C parameter. So here, the author has actually provided more than one command. The first one is null, it does nothing, and then it sleeps for 30 seconds. And after sleeping for 30 seconds, as you can see here, it is listing the current content of the directory. If this command succeeded, it means that the application is vulnerable. How are we going to try this? We can use, probably we can use curl. Can I copy this? Okay, curl. First, let me go back to the URL, copy the link. Okay, and then we check the path. This time, let's try to make it sleep for less than 30 seconds. So probably 10 seconds. So we have this response command not found. We can remove the URL formatting, the space here, and use plus sign. Use the same. And I'm going to use the -s. Still we have command not found. If we remove, we have duplicates here. You can remove the mbilling. So it is one mbilling, it's one path, mbilling /lib iSpay.php, and we have all of this is set up. Let's run. Okay, now we can see that it is hanging. It's taking some time to respond, and that's because of the sleep command. Now that is an indication that the sleep command was executed, right? Now if we increase the duration, just to make sure that this was successful, now it should hang for around 20 seconds. Indeed, it hanged around 20 seconds. So basically we know that the command injection was successful. What's the next step? Next step is a reverse shell. We can use this Netcat one-liner. The first thing we want to do is to modify the connection parameters. Let's go back to the connection to the victim machine, the attacker machine. What was it? If config, and this is the IP address. Where is the IP? So it's on ENC5, ENS5. This is the IP address. Okay, let's copy that and modify this here, and maybe use the port. Keep the port as is. It's up to you. What is the port you want to use? Okay. First thing I want to do is to check back the command. So clear. So that's the original command. What we want to do, we want to inject the one-liner somewhere here. Okay. Now to avoid any mistakes regarding the formatting and the parameters, what we can do here using cur, we can just go back, cancel all of this, right? And use the URL separately. So now we make a request to this API path or to the file. Next, we define it as --get, and then we use URL encoding, because let's go back here. You see the one-liner has a lot of characters, spaces, and so on. So we want to properly encode this. That's why in cur we can use --URL encode, right? And then we provide the parameters. Don't forget that we need to provide the demo C parameter. So demo C, okay, and then remember that here to trigger the payload, we're gonna have to first provide a null command followed by the desired command, or you can't just provide no commands. So here we can just use semicolon, right? One semicolon followed by the actual one-liner. So that's the one-liner. Going to paste this and end it with a semicolon. Now before we execute this, we're gonna have to run a listener. So nc lvp 4547, I believe. Okay, let's try. And take a look here, we have a shell. So ls, or maybe who am I? So we got a shell as asterisk. We want to escalate the privileges. Probably here we are with on a Linux operating system. So basically we want to first find out what are the current privileges associated with the user we have, asterisks. So to do that, we can use sudo -l. And we can see the commands that can be run as a root or as sudo. So we see here user bin failed to ban client. This command can be run with elevated privileges, and no password is provided. No need to provide passwords. First, we have to find out what is actually failed to ban client. So basically, failed to ban client is a command line interface that you can use to interact with the failed to ban server. So failed to ban is a tool that allows you to monitor security logs on your server and then take action based on the monitored logs and based on the patterns. If a pattern is matched, you can take action such as banning an IP address. So to have a look here, first let's find out if failed to ban is a running process and what is the user that is running this process. So you can use ps-aux and then grep fail to ban. Indeed, there is a failed to ban server running, and it is running as root as expected. So if we take over this tool and we configure it in a way to run our own commands instead of the intended commands the tool is supposed to run, we can actually run our own commands then as root. First, we have to actually understand the configurations of this tool. First, we have to check the configurations of the fail to ban server. So basically, in fail to ban, the configurations run as jails. They are called jails. So to find the active configurations or to find the active jails configured, we have to use sudo and then the path to the tool. So the path here is, let's see here. This is the path. Dash, or without dash, status. Okay, in the app we see number of jail is 8. So I have 8 active jails configured to run. Jail list, these are the jails. So the thing is here, we want to take control of one of these jails and let the jail run the action we want, which is elevating the privileges. So understand that jails are basically configurations that define which logs to monitor and the patterns to look for, and of course the actions to take when the pattern is matched. So let's have a look at one example of these. So the one that could work for us in the scenario is this. How do I know? Because I tried this before streaming the video. So now *-IP tables, we can have a look at this path. So we can do nano or maybe cat, and the path to the jail can be found at etc fail to ban and then jail.local. Okay, here we can see the full configurations using jail.local. All right, so here we have the default one, *-IP tables. Let's have a look here. So here enabled the filter, the action. This is the action that is taken when a pattern is matched. IP tables, all ports. So here an action is performed by the firewall, right? The log path, that's the log file being monitored by this jail, *-IP tables. So this jail monitors this log file, and if there is a pattern matches the asterisk, it's going to trigger the IP tables -all ports rule in the IP tables firewall. Now, to exploit this, we're gonna have to modify the action. Okay, modifying the action to execute a command of our choosing. Okay, now let's have a look specifically at this. You can actually display the configurations of a specific jail by running this command. So here sudo user and we can use git followed by the name of the jail. The name of the jail is Asterisk. Tables, wait. And here we can use the keyword actions to take a look at the actions. Command not found. Here we have the action that's taken on this jail. The jail asterisk IP tables has the following actions. IP tables, all ports, asterisk. So we want to modify this as stated earlier. We want this to be modified to a command that we run to elevate our privileges. The closest one is setting the UID bit on the bin bash, right? So when bin bash is executed and the set UID is set, we're going to have a root access. How we're going to do this? The first thing we want to do is to have a look at the actual command that is executed when this jail is triggered. So to do that, we can use sudo. Then let's copy this and use get followed by the name of the jail. The jail we are examining is this *-IP tables. And then we use the keyword action because we are actually investigating the action associated with this jail. The action name is this. We have it already. And then use the keyword action ban. As you can see, this is the action that's taken in the IP tables firewall when this jail is triggered, right? IP tables -I F2B *1-S, so it's banning an IP address. So now instead of banning an IP address, we wanted to set the UID bit on the bash shell. So we can just, what we do here, you can use the same command, and we cannot do that because we have to elevate the shell. Okay, let's copy this And here we can define the action ban. The action ban is the actual command that's executed. Now here we can use chmod, setting the UID bit, and specify the binary, which is bash. Okay, next thing we want to verify that this has been successful. So we're gonna retrieve the action ban one more time to see what it is now. And it is still the old action ban. And the reason is because here, instead of get, we have to use set. Get retrieves the existing action ban. However, set configures the existing action ban to our desired one. So we're gonna have to modify the command. And here use set. And then we have to just copy the old command and execute. Looks like it worked right now. Right now we're going to retrieve or verify the action ban. Gonna copy this again. And now the action ban is changed into this one, which sets the UID bit on the bin bash. The next thing you want to do, you want to execute the failed to ban client in sudo mode and in a way that executes the action ban we have set. Now, the way to do this is banning an IP address, because that's the purpose of the tool, banning an IP address when an action or when a trigger is met. This time we're going to ban an IP address manually, okay? To do that, we're gonna have to have the same command here over. Let's copy this, paste, and then set, followed by the name of the jail. So this is the name of the jail we're working with. And to ban an IP address, we can use the keyword ban IP, right? And then use an IP of your choosing, such as 1111. What happens here is we are actually activating the jail asterisk tables. When the jail is activated, it's going to execute the action set in its configuration. We have already changed the configuration of the action ban using these commands. So now when we manually trigger this jail, it's going to execute the action ban we have configured. The way to manually trigger the jail is to ban an IP address. So now if we hit enter, we have 1. Okay, it means that the ban was successful. Now to verify this, we're gonna have to investigate or to have a look at the bash shell configuration. ls-la bin bash. Let's have a look here. And now the bash has the UID bit set. Okay, now this means that it is time now for the sudo bin client to execute it, right? So that we execute the bin bash as root. So maybe we can do this, bin bash -p. Let's have a look at the ID now. The ID is root. Cat root text, and we have the root flag. So the challenge is done. It was a nice challenge actually. We still have the user flag missing. Okay, so here we're gonna go to cd or maybe ls home Magnus. Now we have the user flag.